Okay, let's do set 2 problems for lesson number 7 and here in chapter 3. And let's just review here. Problem number 4. Here are directions for a number trick and part of the table to show what happens if the trick is done with several different numbers. So we're supposed to think of a number. Now what they're doing for us is they're thinking of a number. In fact, they're thinking of 5 different numbers. So you have a chart here that you're forming, or a table, and they're showing you what you would do with that particular number. In the first case, we have 7. So if you subtracted 3, let's just go ahead and put the actual steps. So you're supposed to think here, think of a number, right? And think of this as x, okay? This is going to be x. Think x. Now, x in this case, the first one, it's going to be 7. The second one will be 2. The next one will be 0. Then we have -4 and -10. So we see that x could really be anything. They're giving us a series of operations or tasks to perform. And we're going to follow each one. It says subtract 3, so I would have -3. So now think of it this way. We're supposed to go with subtract 3. So think of this, x minus 3, right? Isn't that what we're doing? So whatever x is, we're going to subtract 3. So in the first case, we have 7 minus 3 is going to be 4. Then they're also saying multiply that by 2. Well, what would that look like? Well, that would look like this, actually. 2 times x minus 3. And notice I put parentheses. So it's 2 times parentheses x minus 3 and parentheses. And in this case, I mean, we're just going to follow over here. We're going to multiply that by 2. All right, but notice if you put 7 in here and you subtract 3, you get 4 times 2 is 8. So if we're just following it, going step by step, we'll certainly be able to do it as well. But I want you to see here why we're doing this. This isn't just to simply give you a set of instructions and you can do simple math. It's to introduce to you the thought of having a variable or a number which could be anything. We've defined it with 5 different numbers here, and you can do all of this wonderful math, and you can figure out what all of these blocks are that we don't have. Okay, so what would the next one be? Well, we're going to add 8. So what would that look like? Well, that would actually look like this. 2 times parentheses x minus 3 plus 8. Wouldn't it look like that? All right. Now, if we add 8 to 8, we know we're going to get 16. So here's our first block that we're filling in. Then we're going to divide all of this by 2. Okay, so I'm going to rewrite this over here. So it would really look like this. 2 times parentheses x minus 3 plus 8 all divided by 2. Okay, and if we simply took our value from here and we had 16 and we're going to divide that by 2, that would give us an answer of 8. Okay, and if we put our number 7 in here, we would actually get the same problem, same answer. 7 minus 3 is 4. So what do you have? So you have 2 times 4 is 8. So you have 8 plus 8 is 16 divided by 2 is 8. Okay, so you can see that this expression is building by doing different functions. And now we're supposed to subtract the number that we first thought of. Well, again, we're going to have to rewrite this whole thing. What was the first number we thought of? Well, it was x, right? So 2 times x minus 3 plus 8. And all of this is being divided by 2. Let me go all the way across. And so all of that's being divided by 2. And then we're going to subtract x at the end. So all of this, I mean, if you wanted to put a bracket around this, you could. You'll start seeing a lot of that, or that a lot more in Algebra 2, where we use brackets on top of parentheses simply because we have to show the parentheses within parentheses, so we use brackets. Nonetheless, this is the expression. And if we simply took what we had here, which was x, in this case x was going to be, or was 7, and we subtract it from 8, we know the answer is 1. Now let's see, does that work the same here? Well, let's put in 7 minus 3. We're going to do the parentheses first, right? And 7 minus 3 is 4. So now we can go ahead and multiply right to left. 2 times 4 is 8. Now I have 8 plus 8, so now I add those together and I get 16. 16 divided by 2 is 8. And subtract 7 from 8 and I get 1. Okay, so these steps that we're seeing here are being represented by the expression that I'm putting in here. And though they do not put that expression in there, I thought it would be good for us to take a leap to look at why we're doing this, what it is we're doing. And so you can see how that number, which they say in the beginning, the number trick, and think of a number. Remember, the number we don't know, it's not defined, so we can use a variable. In fact, we used x. We could have used any variable. It's always good to use x. It seems like x is the favorite one for many years, and the mathematicians chose x for whatever reason. Now, maybe because we use an x on a treasure map, and we're always looking for the treasure, and the treasure in math is to find the answer. What is x? So, I don't know. I just threw that out there. Maybe it is, maybe it's not. Now, we're told to do this for all of these, so you can go ahead and just simply do it. I mean, it's going to do one more column here. Let's just say, well, we think of a number and they say it was 2. Okay, so 2 minus 3, well, that's going to be negative 1. Is that not? 2 minus 3. Then we're going to multiply that by 2, so I would now have negative 2, all right? Then I'm going to add 8. So negative 2 plus 8, well, negative 2 plus 8. Oh, 8 is 2 plus 6, right? Let's just think of that over here. And this is, remember, we're talking about when we offset. And we have 2, we're going to add 8, right? So I can look at this as 2 plus negative 2 plus positive 2 plus 6, right? Because 8 is 2 plus 6. Now, the reason I did this is, hey, I get rid of this. That's 0. So it's 0 plus 6, and the answer is 6. Now, again, I'm just re-emphasizing that method that I'm hoping that you will consider rather than trying to use your negative toes and negative fingers, which you do not have. So the answer, again, was 6. Now we're told to divide that by 2. That was the next step. So divide that by 2, I get 3. Now I'm supposed to subtract the original number, which was 2, and what do I get? 1. I have a pretty good feeling that every time we do this, it's going to be 1. The answer in the end. I believe these will all be 1. Now you're going to go ahead and do it, and you can certainly find out what it is. Let's take a look at this from the number trick. Show how the trick, this is letter B, show how the trick works by illustrating the steps with boxes and circles. So let's go back to our number trick. We are to think of a number, and we're told that when we are thinking of a number, we're supposed to use the box, right? The box is the unknown. What's in the box? We don't know. Now we use circles to show true values when we're adding and when we're subtracting, right? So that's what's the first thing we're told to do. Okay, we're told to add or subtract 3. So we're going to go with those solid circles, right? That's what we're told to do. So now we have the box or plus negative 3, or because we're adding. We can't show you physically something being removed. So we're going to use these negative circles. So we're adding the negative circles, which represents subtracting 3. Okay, so what's the next step? Well, we're supposed to add 8. Now, I'm sorry, we're supposed to multiply by 2. Let's not add 8 yet. So when we multiply by 2, we're multiplying everything by 2. Notice how we have the parentheses over here, x minus 3, and we're multiplying. If we were to use the distributive rule, we would multiply 2 times x, and then 2 times negative 3, or just put 2 times x minus, and then 2 times 3 would be 6. So this would actually be something like this, right? 2x minus 6. So we're going to multiply this by 2. So that means we should have 2x's, which is the 2 boxes, right? 2 unknowns. We're multiplying everything. And we should double up on our negatives, right? So we have 1, 2, 3, 4, 5, and 6. Okay, so we have 2 boxes, which are the unknown, and we have 6 because we've doubled the previous expression. Now we're told to subtract, oh, excuse me, not subtract, but we're told to add 8. Now we're adding 8, and we have that here. Now we didn't necessarily express this way. We just built this expression. We could have had it that way before. There's a simplification process, but we simply just followed what they were showing us. But in this case, now we're going to start seeing how it could be represented, and we've already shown that to you here as 2x. Is this not 2x? And this is minus 6. Now let's add 8. So when I add 8, if I were just to use this as my little guide here, right, I'm just going to put 8 of these guys here. All right. So I'm going to have 6 plus 2, so that's 8 of these, right? Now I'm just adding these because these are positive. So what would my expression now look like? Well, or what would my boxes and circles look like? Well, I would still have 2 boxes because we're not messing with the 2 boxes at all. We're just simply adding 8. Now we know that these guys are just going to cancel each other out, right? So let's cancel these all out. And what am I left with? Well, I'm left with 2 circles, right? Ah, okay. So now we have 2 boxes and 2 circles. Now you might say, but Mr. Cartagena, that looks nothing like this over here. Well, if we were to simplify this process, right, and were to distribute, and in this case, we would have just taken this expression here and we would have added 8, right? Because this is 2x minus 6 plus 8. Well, when we add the negative 6 and the positive 8, it would have given us positive 2. So this expression here, if we simplified it, it would actually look like this, 2x plus 2. Would it not? Simply by doing the math and applying it, getting rid of the parentheses. So now we would have had 2x plus 2, and that's exactly what we have over here. They're positive now because we got rid of these solid circles which represented negatives. Now we're told to divide these by 2. Well, remember how we did that in that picture? We divided this and then we divide this. So what do we end up with? Oh, well, we end up with 1 box and 1 circle, right? We're dividing by 2. So now we divided this by 2. We have to divide them both by 2. Okay, we're not just told to divide one of them by 2. Now, if we would have had this expression here, we would have had 2x plus 2 divided by 2. Now, you might say, well, Mr. Cartagena, how did you end up with x plus 1? Well, I'm going to have to move this over here. And this is a sneak preview as to what we're going to be doing in the future. 2x plus 2 over 2. Well, I can factor here. He says, well, I'm not able to do this with the plus sign. They're not multiplying. But I can do the reverse of the distributive rule. And I promise you that we're going to be doing that quite a bit. So what would I write? I would say, well, what number can I pull out of this 2x plus 2 and say if I multiplied, in other words, I'm dividing this and pulling it out, I'm going to say, well, 2. I probably didn't word that properly. But what would this expression look like? I mean, we could say, for instance, 6 is also 2 times 3, right? So what could we do? Well, I see a common factor here of 2. And how can I express it? Well, I'm going to pull the 2 out. And I'm going to say 2 times parentheses x plus what? Well, 2 times x is 2x. 2 times what is 2? Well, 2 times 1 is 2. I hope I didn't go too fast there, but this is exactly this. It's just I did the reverse. I pulled it out. Now, of course, we've changed this expression from the very beginning, and we had it up here as 2x minus 3, which became 2x minus, or 2 times x minus 3 with the parentheses. Sorry, I said that wrong. The proper way to say would have been 2 times parentheses x minus 3 and parentheses. Now, we ended up with 2x minus 6 once we distributed, but remember, we added the 8. It changed our expression. Now we can undo the distributive rule, and that's what we did here. Now, why would we do this? Well, now we have factors that we can eliminate. We can cancel out the 2 and the 2. And what am I left with? Well, look at this. X plus 1. Isn't that what we have here? X plus 1. So you can see what we did here with these boxes and circles was pretty much the same we could have done with these numbers and variables. And just again, I want to go back to this whole issue of factoring. I think we used, let's say, 12 divided by 2. Okay? And we can use this as an example. Well, we can say 12 is the same as 2 times 6, right? Divided by 2. And then we can cancel out the 2's and say, well, this is 6, right? It's 6 over 1 or 6, which is what 12 divided by 2 is. But you need to be careful. You can only do it when we have factors, when we see multiplication solely going on with these factors. We used the example in the past of, well, what if I would have said 12 divided by 2, and then I would have said, well, that's the same as 2 plus 10, is it not? Yeah, it sure is. Now, if I would have done it this way and said, oh, I can now eliminate these, well, now my answer is 10, and that's not true. What I did here was illegal. That was an illegal operation. I could not factor those two out. Because 12 divided by 2 is not 10. We know it to be 6. So that's why we must be very careful. In this particular case over here, we may have been tempted to have gone just to say, oh, I could eliminate that. That's the 2 and the 2, and I'm left with x plus 2. Well, that would have been wrong because it's not x plus 2, it's x plus 1. Why? Because we had to factor. Again, that's a sneak preview what's coming in the future. But let's just finish up our problem here. And what are we told now? We're told to subtract the x, or the unknown, or the number, let's call it, the number. And what happens when you subtract a box from a box? You end up with the 1 circle. So here you could see how, using the illustration of the number trick, we would have gotten the same answer. And it really goes to show that no matter what you put in here as a number, you follow these instructions, you're always going to end up with 1. Because you can put any number here to represent this box. In this case, it was 2, boom, 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 boom. 2, 2, 2, 2, 2. You would have seen the same answer. I know I'm kind of just bouncing over. But no matter what this is, if you follow these operations, you will ultimately still end up with 1 as your answer. So that was a very thorough approach to this particular problem, and we'll try to do that with some of the others as well.